Assalamualaikum and hello everybody. My name is Siti Noraini binti Ali and I'm environmental health student. My ID number DIT 121902222. Now I'm going to be talking about enzyme. What is an enzyme? Enzyme is the protein that speeds up the rate of a chemical reaction in a living organism. An enzyme acts as catalyst for specific chemical reaction, converting a specific set of reactant called substrate into a specific product. Without enzyme, life as we know would not exist. What factor that influence enzyme? First is temperature. A most active at an optimum temperature, usually around human body temperature 37 degrees Celsius for the enzyme in human cell. Show little activity at low temperature, less activity at high temperature as nutrition occurs. Second is pH. Every enzyme has an optimal pH in which it works best. Vaccine digestive enzyme is Thomas RH2. Trypsin digestive enzyme is more intensive RH8. High or low pH value than optimal value will cause ionization of enzyme which result in dehydration of enzyme. Third is cofactor and coenzyme. Cofactor is a substance of the substrate whose presence is essential for the activity of an enzyme. Coenzyme is an organic non-coating compound that binds each enzyme to catalyze a reaction. Different for coenzyme and cofactor include molecule types, range, straight, removal, and roll. Example: organic molecule bind loose with the enzyme can be removed from the enzyme easily. Help in biochemical transformation, an example vitamin and biotin. Cofactor can be either organic or inorganic molecule, can bind either loosely or tightly, can only be removed by denaturing the enzyme, help the enzyme to carry out their function, an example magnesium enzyme. Inhibition. An enzyme inhibitor is a molecule that disrupts the normal reaction between an enzyme and a substrate. Enzyme inhibitor prevent the formation of an enzyme substrate complete and hence prevent the formation of product. At the below have 4 types of inhibitor. Competitive inhibitor. Competitive inhibitor involve a molecule other than the substrate binding to the enzyme active site. The molecule inhibitor is structurally and chemically similar to the substrate, hence able to bind to the active site. The competitive inhibitor block the active site and thus prevent substrate binding. As the inhibitor is incompetitive with the substrate, it in fact can be reduced by increasing substrate concentration. Non-competitive inhibitor. Non-competitive inhibitor involve a molecule binding to a site other than the active site and allosteric site. The binding of the inhibitor to the allosteric site causes a conformational change to the enzyme active site. As a result to this change, the active site and substrate no longer show specificity, meaning the substrate cannot bind. As the inhibitor is not in direct competition with the substrate, increasing substrate level cannot mitigate the inhibitor effect. Uncompetitive inhibitor. Uncompetitive inhibitor bind at a site other than the active site. Other site than the active site can be bound to by a regulatory molecule and have a positive effect in fact, not all inhibitory. Competitive inhibitor do not bind to the enzyme until it has bound to the substrate. Enzyme substrate complete. Once uncompetitive inhibitor has bound, substrate remain associated to the enzyme. Irreversible inhibitor. Agent that bind to enzyme irreversible to enzyme and discharge their function are irreversible inhibitor. Easily bind via convolute bonds. Tend to be highly toxic. Any of the following inhibitor can become irreversible if convolute modification occurs. What is the law and K concept? Enzyme is law and substrate is the K. Enzymes are specific in action due to the shape of the active site. Enzymes have an active site with specific shape that only a low substrate with complementary shape to fit into. Example, such molecule only fit into the enzyme amylase. The enzyme and substrate form an enzyme substrate complete. The activation energy of the chemical reaction is lower. This substrate is then broken down or blown up into product. Mention breakdown or blown up depending on the type of reaction. The product then leaves the active site of the enzyme. The enzyme remains unchanged and can be used to catalyze another chemical reaction.